In this lesson, we're going to explore the relationship between two categorical variables. So here is some information from a local high school. For the white students, 198 went to four-year colleges, 36 went to two-year colleges, 4 went to the military, and 30 entered the workforce. For minority students, the numbers were 44 to a four-year college, 6 to two-year colleges, 1 to the military, and 6 entered the workforce. So what are my observations of the data? Well, it's kind of a lot going on, and so what I can do is create a contingency table. The contingency table basically makes it easier for me to look at by each race, so white or minority, or I could look at four-year colleges. So for a four-year college, I can look at the number of whites to minority students and total. So it basically just is a way for me to look at one categorical variable versus another categorical variable. So this is post-secondary plans versus race. So these also have marginal distributions, and the marginal distributions just means whatever is in the margins. So the marginal distributions are important. If I wanted the marginal distribution of race, that would be the 268 and the 54. If I wanted marginal distributions of post-secondary plans, that would be these values, because that's what's in the margin for the different options. So based on the data, let's take a look at some questions that you might get based on a contingency table. So what percent of the students were white? So again, we're dealing with percentages. So I'm looking at white students, which would be 268 students divided by 322 total students. Then of course we would turn that into a percentage. Now when you're doing these, it's super helpful to go ahead and write the fraction first and then the percent, so that if you're, say, submitting something to me, then I can take a look at it and see where you're making your error. The percent of whites that went to the workforce, so this is a little bit different now. We're not going to use the 322 of the total because we're only interested here in percent of whites. So I'm looking at 268, and that went into the workforce would be 30. So my fraction would be 30 over 268. So 30 over 268 would be 11.2%. Remember, when I divide that, I get 0.112, etc., and then I change it to a percent. What percent of the students who went to four-year colleges were minority? So again, I would look at the percent of people who went to a four-year college, which is 242, and minority would be 44 out of those 242. So again, it's really important to look at what is your population. Here the population is percent of students who went to four-year colleges, which would be the 242, and then how many of those were in the minority. What percent of minority students did not go to a college? So again, now my population is minority students. So what percent of minority, that's the 54, did not go to college? So that would be the military and workforce people who didn't go to college. So only 4 out of 54, which would be 7.4%. The last one, what is the marginal distribution of race as a percent? So marginal distribution of race would of course be whatever in the margins for race. So that's these two values, but notice they want it as a percent. So really I would just find the percent of 268 out of 322 and 54 out of 322. Now we also have conditional distributions. So that was a marginal or contingency table and some marginal distributions. A conditional distribution basically gives us all of that data that I just had on the other contingency table, but it breaks it down. In this case, this is contingent upon race. So now I've got white students and minority students, and I can look at these percentages and then compare to see if white and minority students have the same post-secondary plans. So looking at it now, it looks like more minority students went to a four-year college than white students did. A few more white than minority went to two-year colleges. Looking at the military, those are fairly similar, but this one is kind of a big one. It looks like 11.19% of white students go straight to the workforce, while only 5.56 of minority students do. So again, now that's conditional because it's conditioned based on race. Now, independence is something that a lot of students struggle with. When I'm looking at independence, I'm determining whether whatever factor I've chosen, in this case race, I'm saying, does race have an effect on post-secondary plans. So looking at those values that we just went through, it seems like race does have an effect on post-secondary plans because these percentages are not the same. These percentages are not the same. Now, we don't expect them to be exactly the same, but there's a pretty significant difference between the percent of white and minority students that go to four-year colleges and the percent of white and minority students that go straight into the workforce. So those are two kind of big differences. And so I would say that these are not independent, because looking at them, I can see that there's a difference in, based on race, what the post-secondary choices are. Now again, you can do this graphically as well, and graphically is a really good way to just be able to look at something and make that determination. So here are two different types of ways to graphically compare contingent data. For here, I've got my white and minority students in a segmented bar chart, and segmented basically goes by percentages up to 100. So notice each bar goes all the way up to 100 because it's all 100% of the white students and 100% of the minority students that we surveyed. And looking at that, I can look at the blue and say, well, white obviously doesn't go to a four-year college as often as a minority student does, but whites go into the workforce more often than minority students do. I can do the same thing over here in a side-by-side pie chart, because pie charts, again, give the percent of the whole. So that's what these two have in common, is that they both give percents of the whole, and I can look at, each specific pie slice to make those determinations. Here are a few questions based on the contingency table of passengers aboard the Titanic. I would like you to answer all three questions. Press pause, then answer all three questions, and then press play to check your work. So here we're looking again at different classes aboard the Titanic and what their fates were. So what percent of passengers and crew survived the Titanic? So that's percent total who survived. So people who survived, that's the people who were alive. Out of the total, we would do 711 over 2201 and get a percentage of 32.3%. For the next one, the conditional distribution of survivors based on class. So we're looking at conditional based on class. So I want to know survivors on first class, survivors on second class, third class, crew, etc. So again, I want you to notice that I'm looking at 203 out of 325. So what percent of first class passengers survived would be 203 out of 325. Second class passengers, there's 285. So notice I'm not using the 2201. I'm going based on class. And looking at these values, it's very clear some of the patterns that we can see in the data. Because first class passengers, 62.5% of them survived the Titanic, as opposed to 25% or 24% of the third class or the crew. So looking at question 3, does survival seem to be independent of class status? If it were independent, all of these percentages would be the same. These are not the same percentages. So it does not appear that they are independent, because first class passengers survived like 2.5 times as often as a third class or a crew passenger. I want to show you how you can actually do those calculations within my stat lab. So as you can see, I have one of our questions from Mod 1 homework. Yours will be very similar to this. As we can see, this is certainly a contingency table type of question. I've just clicked on this little button here and opened in StatCrunch, and as you can see, that's the data that's over here. So what's going to happen now is I'm going to work on answering these questions, just letting StatCrunch do all of the work for me. So the first question says, what percent of all applicants were Asian? Which means we're looking at total Asian, which is 470 out of 1375. So I could just divide those two values. But if I go to Stat, Tables, Contingency, with summary, that's what I'm going to do each time. Now be careful what you choose here. So obviously I'm going to choose the data that has the numbers in it. So notice I did not choose ethnicity, because that is not the data, that is just sort of the labels for the data. For the row labels, I'll choose ethnicity. And then down here, this is what's going to help us to know. We don't have to worry about anything below that, the confidence interval, the hypothesis test. Because I want percent of the whole, I'm just going to do percent of total and compute. So if I have percent of total and I'm looking for percent of all applicants who are Asian, that's going to be 34.18, and I'm going to write that as 34.2 and check my answer. So now I'm looking for the percent of students accepted who were Asian. So I'm looking at in this column, in the accepted column, so I'm going to go back to options, edit, and column percent and compute. And if you'll notice what that did is now the column total is 100%. So the percent within the accepted that were Asian is 27.03. So I'm going to write 27%. Next one, percent of Asians who were accepted. So now we're looking at the row of Asians, which is 470, and the percent that were accepted is 50. But again, if I want to let StatCrunch do that work, I'm going to go back to edit, and I'm going to check row percent instead. And now as we can see, we've got the 100% at the end of each row. So Asians were 10.64, which is 10.6, and check my answer. So again, I'm not having to do any of the work. And then the percent of all students who were accepted, again, I would go back to that original where I did percent of total, and then all students that were accepted is the 185 out of 1375, which is 13.45%. Now be careful on this one because StatCrunch is automatically rounding to 2 decimal places, which means this could be 13.447, which means over here I'm going to get that wrong if I put 13.5. If I round this, it's 13.5. So this one I would actually take my calculator and check. So just to be safe, because I don't want to have to do that whole question again, I'm going to do 185 divided by 1375 just to make sure that I'm rounding it correctly to one place, and it's going to be 13.5. And that's how you would do all of that in my StatLab or StatCrunch.